Hi everyone, it's 5:30, so I'm going to go ahead and get started. So my name is Kaylee and I am the guided study group leader for this course. A little bit about myself. I am a rising junior and I'm majoring in business management and economics. I'm from right outside Harrisburg, Pennsylvania, and I'm excited to be here. This is my third semester doing this, so the summer session course isn't much different than the other two, I'm pretty sure. So I'm pretty used to it by now, but hopefully these sessions will make it easier for your learning. So today I'm going to familiarize you guys with Canvas if you don't know where these problems are coming from, and then I'll also go over both lessons 1 and 2. So this is probably the longest lesson of the entire course. The other ones you'll see in the future are shorter. I'd say that in the future they probably average around like 45 minutes. Some of them are even as short as 20 minutes. It just depends on the practice problems for that week. So looking at Canvas, this is just a screenshot of what I would see. So you're under modules and then you scroll down until you find the first lesson and click on it. And then in that lesson, you'll see a tab that says Lesson 01 Extra Practice. And then clicking on those, you come to what I'm about to go over. So pretty straightforward, nothing too complicated, but I'm going to get started right away with lesson 1. So the first problem is about Pareto efficiency, and it gives you this big long table that we have to interpret. So it says, consider a labor market in which there are 10 firms and 10 workers. Each firm can hire only one of these workers, and each firm has a maximum it would be willing to pay the worker. It would like to hire its worker for as far as below this maximum as possible, but if no other options exist, it will hire a worker at a wage equal to its maximum willingness to pay value. The maximum wage each firm is willing to pay is shown in the table. And it gives you the second part. Suppose that each worker in this market can work for only one firm. Each worker has a minimum wage that will be acceptable. Any offer below this minimum will be rejected, and the worker will not participate in the market. Each worker would like to be hired at a wage as much above the minimum acceptable wage as possible, but if no other options exist, they will work at a wage just equal to this minimum. The minimum wage acceptable to each worker is also shown in the table. So pretty straightforward stuff, and then it asks you a series of questions. So number 1 says, suppose that the first 8 workers are hired by the first 8 firms, and each worker is paid a wage of $380. Show why this is a Pareto efficient outcome. So when we talk about Pareto efficiency, what we're saying is we want some kind of outcome that makes it impossible to change that outcome in a way that will make someone else better off without making someone else worse off. So in this case, this outcome is Pareto efficient because there's no way any of the remaining firms or workers can reach an agreement that is mutually beneficial. So if we were to increase it to 9 workers, that's better for person number 9, but it's worse for the firm because they're now paying above their maximum. In the same case with firm number 10. So far, with the wage of $380, both the firms and the workers are satisfied. So then number 2, it says, concerned that workers will be exploited by firms, suppose that the government passes a law that prohibits deals below $480. That is, individuals and firms must contract for work at $480 or above. What will be the consequences of this law? So the consequences of this law, we see that they would only allow firms 1 through 3 to hire, but also all the workers would be willing to work since their minimum acceptable wage is below $480. So this outcome would not be Pareto efficient because mutually beneficial deals can still be made, which we saw. So deals that were made in the first question could still be possible, but because now they're not, it's not Pareto efficient. Next question. Assuming the Pareto efficient outcome from 1 would have emerged without government interference, which workers gain because of the law, and 2, how much do they gain and who loses because of the law, and then how much do they lose. So this one has multiple parts that requires a little bit of math, but my best advice would be to take it step by step. So looking at who gains from this law, workers 1 through 3 would gain because they're still being hired. And they're also gaining an extra $100. So in number 1, they were all earning $380. And now in scenario 2, they're all earning $480. So that's an increase of $100 for each person. So then the 3 firms that hire them end up losing because they're losing that $100 from having to pay it to the workers from this minimum wage law. So thinking back to scenario 1, that $100 would not have been given, but now it's being given in scenario 2. So those 3 firms also lose $100. So far, looking at our information, we see that the workers gain a total of $300 and the losers, the firms, lose a total of $300. But looking more at it, there's still some more people who lose. So those people would be these 5 workers, 5 through 8, that weren't hired, or 4 through 8 that weren't hired. So these workers have been shut out by this law, and originally they were making $380. But this law might require them to go somewhere else and find jobs that might only offer them their minimum acceptable wage. So essentially what they're losing is the difference between what they were making and what their minimum acceptable wage is. So for worker number 4, they're losing $80 because that's 380 minus 300. Worker number 5, they're losing $40 because, no, they're losing $60 because, oh, I see now. I made this table wrong. So for person 5, that should be 320, and person number 6 should be 340. So for person 5, they're losing $60 because that'd be 380 minus 320, not 40. Person 6, they'd be losing the difference between 380 and 340, which is 40. 7, that'd be 20, and then 8 is 0. So then adding up all those differences, that comes to a total of $200 lost. So hopefully you're following along with me still. We had the firms 1 through 3 lose $300, and then the workers 4 through 8 that weren't hired lose a total of $200. So that brings us to a total loss of $500. So there's $500 lost in total, and then $300 gained in total. And each of those impact different people. So that question's a little harder to understand, but you really have to just evaluate this table. You have to analyze this table. So then for number 4, it says, is it possible for the winners in number 3 to fully compensate the losers and still come out ahead? If not, how could such a law be justified? So what I just said with the total amount gained and lost, now that's what you're looking at. The winners gained $300, which doesn't fully compensate the lost $500. So they're not able to compensate the full thing and they can't come out ahead. So when thinking about laws to justify this law can only be justified using principles developed outside of economics. So nothing we've learned in the course so far can help us solve this problem. You're just recognizing that this law is outside our potential. So then number 5, suppose the maximum willingness to pay values in the table above represents values for a single firm that is the only buyer of labor. Also, suppose that this firm is aware of each worker's minimum acceptable wage. In this situation, the firm could offer the first worker a wage of $240, and since the only other option would be to not work at all, the worker would accept. Similarly, the second worker could be offered a wage of $260. The first would still earn $240, and he would accept. How many workers would be hired under this pay scheme? So under this pay scheme, we can see that everyone is going to be paid exactly what they want. So then we have to think on the margin, which is something you've probably heard before. So with this idea of thinking on the margin, we want to produce or hire people up to the point where the marginal cost equals the marginal benefit. So in this case, it's going to be where the maximum acceptable wage equals the minimum acceptable wage. So this is going to be up to worker number 8. Because thinking about it, if the maximum acceptable wage is less than the minimum acceptable wage and the firm still hires them, they're going to be hiring them at a price greater than what they're capable of. So they're going to be losing money. So because of this, we want to take a step back and just hire up to the point where the two equal each other. And then lastly, is the answer to number 5 a Pareto efficient outcome, and is it an equitable outcome? So it is a Pareto efficient outcome because no mutually beneficial deals still exist. You can't make some kind of change that would make someone better off without making anyone worse off. The only options remaining makes at least one person worse off. And then we see, though, that this isn't equitable because the firm is taking all the benefits. The workers aren't gaining anything extra. They're all being paid differently. The firm is totally in control, and they're the one who has all the power. So it isn't equitable. So that was all of lesson 1. It was just analyzing this table. Hopefully you guys are able to follow along with that and understand what the questions were asking, or I helped with that. So I'm going to move on to lesson 2. So lesson 2, the first couple problems or so are all equilibrium, which are all very similar. So I'm going to start with number 5, which is the table, because the last 2 or 3 problems in the course are a little more difficult. So I want to make sure I get to those first before I do the equilibrium, because with the equilibrium problems, it's really just simple algebra, which if you haven't seen in a while, that's totally fine. But after seeing just 1 or 2 examples, you might be okay. So I don't want to take up too much time just doing that over and over when I could focus on these harder problems. So in your reading, you've probably started to learn about the labor force and how the labor force is made up, and different calculations we can use to look at the labor force and compare it. So the following is actual data from the BLS for January 1990. Solve for the missing spaces, round to the nearest decimal for the unemployment rate. Because of rounding differences, your answers may vary from what's reported below. So that last sentence is a very important point. It's happened to me before. Looking at these answers, or looking at the formulas, just make sure you're plugging in the right things, because a rounding error is very common. So if your answers don't match up with the answer key, or it doesn't look exactly right when you get a test back, that they still give you credit and you're getting confused, don't be alarmed. A rounding error is very common. Just make sure you're really using those formulas correctly and double checking your work. So the trick with these boxes, I guess I'll call them, or tables. Yeah, the trick with these tables is there's multiple ways to solve them. There's not just one way to do it. But with that, I'll be jumping around a lot. So I might start in one place and then I might not go left to right or up and down. Like I'm going to be jumping different places based on what we have. So it's like a giant Sudoku puzzle kind of. So I'm going to recreate this table with my whiteboard and then I'll get started. So as I'm as I'm solving this table, I'm not gonna fill in each of these boxes. So I'm gonna use the letters. So I'll label everything at the end, like, so you'll see what I mean then. But my best piece of advice would be just to follow along on your own paper. So I'll just keep drawing this. So this is the measurement. And we have the labor force, employment, unemployment, and we have another row that I forgot. So this last row is going to be the unemployment rate. And then we have Pittsburgh, Pennsylvania, and then Pennsylvania excluding Pittsburgh, so I'll just do PA minus Pitt. And they give us a couple values already. So labor force for Pennsylvania we have as 5,845,405. On it, the employment for Pittsburgh is 1,067,602. The unemployment for Pittsburgh is 68,359. And finally, the unemployment rate for Pennsylvania, excluding Pitt, is 4.9%. And then I'll go back and label each of these boxes. So the labor force for Pittsburgh is going to be A. Pennsylvania excluding Pitt is B. Pennsylvania employment is C. And then Pennsylvania excluding Pitt is D. Pennsylvania employment is E. Pennsylvania excluding Pitt is F. Unemployment rate for Pittsburgh is G, and then unemployment rate for Pennsylvania is H. And then off to the side, we know our equations. So what we know is that the labor force is going to be the addition of the number of unemployed plus the number employed. The unemployment rate is the number of unemployed over the number of the labor force times 100. And those are actually the only two equations you need for this table. So looking at this table, the best thing to look at is each of these two equations, both of them require 3 variables. So the only way you'll be able to solve them is if you have 1 unknown variable and 2 known variables. So looking at our given information, we can determine which things we know and which things we don't. So I'm going to solve for A first because we have the unemployment amount and employment amount for Pittsburgh. So adding those two together, we can find the labor force. So for A, we see that let me use a different color. So for A, we see that 1,067,602 plus 68,359 that gives us a labor force of 1,135,961. So that is our first answer. So I'm going to put a box around that and then cross off A to show that we've solved for that one and can use it to make future calculations. So the next thing that I'm going to solve for is we now have we have 2 of the 3 labor force numbers. So since we know Pennsylvania and we know Pitt, we can solve for the third column since it's just Pennsylvania minus Pitt. So for B, we can see that the labor force for Pennsylvania minus Pitt is going to be 5,845,405 minus this value we just solved for in A, which was 1,135,961, which gives us a labor force of 4,709,444. And now that we know that, I can cross that off. Also, I apologize if it's hard to read my writing sometimes. This tablet isn't the greatest, but I'm trying my best to make it look legible. So bear with me. The next thing I can solve for, let's see. I'm going to solve for G, which is the unemployment rate. So we know from our equation that'll be the number of unemployed over the labor force for Pittsburgh. So that'd be 68,359 divided by the labor force, which we just solved in A to be 1,135,961. So whatever that answer is, we multiply that by 100. So we get an unemployment rate for Pittsburgh of 6.0%. I can cross that off. Let's see. So if we look at this Pennsylvania excluding Pitt column, we can kind of work backwards. So if we know the unemployment rate and we know the amount of the labor force, we can just rearrange this equation around to get the amount needed for unemployment. So we can see that unemployment is just going to be the labor force times the unemployment rate divided by 100. So that's the big thing with these equations. With only 3 variables, you can move them around easily and transform them to fit what you're trying to find. So going back to solving our calculation for letter F, we can see that unemployment is going to be the labor force, which is B, which is 4,709,444 times the unemployment rate, which is 4.9, and then that whole thing divided by 100. We get an unemployment of 230,762.8. And that was F, so I can cross that off. So easily the next thing to solve for is D, since that's the only thing left in this third column. So we can solve for employment by subtracting unemployment from the labor force. So the labor force, which is B, would be 4,709,444 minus unemployment, which we just solved for, which was 230,762.8. So that gives us an employment of 4,478,681.2. So then finally, all that's left is most of the stuff in this middle column. So C and E you can solve the same kind of way, which would be adding together the value in PIT and the value in PA minus PIT. So I'll solve for C first. So we know that needs to be Pennsylvania minus PIT, which is D, which we just solved for. And then add that to what was given, which was 1,067,602. So that gives us an employment for Pennsylvania of 5,546,283.2. That was C. For E, we can do the same exact thing. So we can take the value from Pennsylvania minus PIT, which is F, which is 230,762.8. Add that to the value given for PIT, which was 68,359. And that gives us 299,121.8. And last but not least, we have H, which is just the unemployment rate, which we know is our fraction given. So that's going to be the number of unemployed, which is E that we just solved for, 299,121.8 over the labor force of 5,845,405. We can multiply that fraction by 100 to give us an unemployment rate of 5.1%. So that is the entire table. I know that it takes a while. It's a lot of math, but really just focus on what you're given, how these columns relate to each other, what order they're in, how you can move around these equations. I would just say, like, the best piece of advice for this table is just to take it nice and slow. But I really don't think it's too troubling. It's just a lot of math. So clearing this, I'm going to move on to the next question. So number 6 is about the unemployment rate and the labor force participation rate. So we're given one more equation to use that we could use that we didn't use in this previous table. So in January 2013, according to the BLS, the population of men 16 years in age and above in the U.S. was approximately 118 million. 76 million of these men were employed and roughly 7 million were unemployed. The population of females aged 16 and above numbered 127 million, with 67 million employed and 6 million unemployed. How do the labor force participation and unemployment rates compare across men and women? So this one's pretty simple. You just write out your given information, which you'll see through these videos that I almost always just make a list of the given information before I start any problem. And then going from there, you can just write out your formulas and plug and chug. So I'm going to start with the men. So the population was 118 million. The number of employed was 76 million. And the number of unemployed was 7 million. So we have to find the labor force participation rate and the unemployment rate. So we know that the labor force participation rate is going to be the number in the labor force over the number in the population multiplied by 100. And then the unemployment rate, which we just solved for in the table, we know is the number of unemployed over the labor force times 100. So with this labor force participation rate equation, we need to know the labor force, which are not given. But we know how to solve the labor force with this equation that we use in the table. Labor force equals employed plus unemployed. So with these equations, we can then solve all of these, which I'm about to do. So I'll first solve for the labor force, which is employment plus unemployment. So that's going to be 76 plus 7. So we see that the labor force is going to equal 83 million. And then we also know with this information the labor force participation rate, which would be 83 million over 118 million. Then multiplying that fraction by 100, we get 70.3%. And then the unemployment rate is going to be the number of unemployed, which is 7 million over the labor force, which we solved for as 83 million. Multiply that whole thing by 100. We're multiplying it by 100 to show it as a percentage. Make the numbers a little bigger and easier to work with. So that becomes 8.4%. So really straightforward, just using the equations. So we have 83 million, 70.3% for the labor force participation rate, and then 8.4% for the unemployment rate. And then we can do the same exact thing with the women. So we see that the women population is 127 million. Employment is 67 million. And the unemployment is 6 million. So again, I can solve for the labor force, which is just adding those last two things together. So employment, which is 67 million plus 6 million. So that gets us 73 million in the total labor force for women. And then solving for the labor force participation rate, we have 73 million over the population of 127 million multiplied by 100. So that equals 57.5%. And then finally, the unemployment rate. That'll be the unemployed over the labor force that we solved for times 100, which equals 8.2%. So comparing them, we see that there's more in the male labor force than the female labor force. And we can also see that the labor force participation rate for men is higher than the labor force participation rate for women. But we also see that the unemployment rate for women is lower than the unemployment rate for men. And then if we wanted to look at the total labor force participation rate, or like the total population data, which I'm going to do in the middle, we can just add each of those together. So for the total, we can do the total labor force, which would be '83 plus 73 over the 118 million in the population for males and the 127 million in the population for females. Multiply that by 100. So we get a total population labor force participation rate of 63.7%. And then looking at the total unemployment rate, we can do the same exact thing and add up the number of unemployed for men and women, which is 7 and 6. And then put that over the total labor force, which is 83 million plus 73 million. Multiplying that by 100, we then get a total unemployment rate of 8.3%. So again, this question is also just a lot of math, but it's just using those equations and plugging in the numbers and solving it out. You'll see in this course that there is a lot of math, but I don't think it's too difficult. Like, I apologize if that offends you in any way. If like you're struggling with it, it's totally okay to struggle with math. Like, it's not for everyone. My sister, for one, absolutely hates math. But I think if you use the formulas and at least understand how to use the formulas and what the numbers mean, then you really shouldn't have too much of a problem. There's no like advanced math or calculus or anything. Like, none of that is here. It's really just some simple graphs later, and for now, just some equations. So then I'll clear that one and move on to the next question. So this one is talking about earnings, compensation, and income. Use the following information to calculate the worker's earnings, their total compensation, and income for 1 month. So what you learned through your notes, hopefully, is that the earnings, compensation, and income all consist of different things, and it's kind of like a building block. Each of them work into the next one. So the biggest thing with this is just knowing what each of these calculations consist of. So we have the wage rate, the units of time worked, health insurance, which right now I'm just copying the table they gave us, Social Security tax, and then interest on investment. And they tell us the wage rate was $10 an hour, time worked was 160 hours, Health insurance was $120. Social Security tax was $100. And then interest on investments was $50. So knowing this, the first thing they wanted was earnings, which is going to be the wage rate times the units of time worked. Wage rate times the units of time worked. So looking at our given information, we see that that's easily 10 times 160, which comes out to be $1,600. The next part, which is total compensation, that's going to be earnings plus employee benefits. That's going to be the $1,600 we just solved for, plus employee benefits, which is the health insurance and social security tax. So we add those two together, so 120 plus 100. So we see that $1,600 plus $220, which comes out to be $1,820. And finally, income is going to be total compensation plus any unearned income. So the total compensation we just solved for was $1,820 plus the unearned income, which is the interest on investments, of $50. So this gives us a total income of $1,870. So this one's also pretty straightforward. It's just knowing what earnings, total compensation, and income, what the formulas for each of those are, or just thinking about what each of those consist of, and then using the numbers to solve. So these were the last three of the chapter 2 that I thought were more complicated than the equilibrium questions at the beginning. So now I'm going to go back and do a couple of the equilibrium ones. I have about 15 minutes left, so I might actually be able to get all of them covered. So to give you a little introduction, the equilibrium wage is a price where firms buy exactly how much they plan to use and workers supply exactly how much they plan to rent. The quantity demanded is equal to the quantity supplied. To find the equilibrium wage, we must solve two equations simultaneously for the two variables, W, which is wage, and L, which is labor. So solve the following two equations for the variables W and L. So the biggest thing to remember with equilibrium is that is where supply equals demand. So if we were to look at it graphically quickly, we had wages. Nope, that's not right. We had wages on the y-axis and labor on the x-axis. And then we had demand, which was downward sloping, and supply of labor, which is upward sloping. And this equilibrium point is where the two intersect. So what we're solving for is these two values that lead to this intersection point. So the first one they give us is labor demand equals 4 minus 2W. And labor supply equals 2W. So since labor is isolated in both of them, and we know that labor demand equals labor supply in equilibrium, we can just set these two equal to each other. So 4 minus 2W equals 2W. So as you can see, the labor goes away because now we can only solve for one variable at a time. So this is saying that labor demand equals labor supply. So, but right now we're solving for W. So solving for W, we can add 2W to both sides to get 4 equals 4W. Now we can divide each side by 4. So we get the wage is equal to 1. So just some simple algebra. And then we can use this equilibrium wage and plug it back into either of these equations to find our equilibrium labor. Because at equilibrium, labor demand equals labor supply, so it doesn't matter which equation you plug it back into. So plugging this back in, I'm going to use first equation. We have labor demand equals 4 minus 2 times the wage of 1 that we just solved. So that gets us 4 minus 2, which equals 2, labor of 2. If you wanted to double check, you could also plug that back into the labor supply, which we see is just 2W, so 2 times 1 is also 2. So for this first question, the equilibrium wage is $1, and the equilibrium level of employment is 2 workers. So then the next 3 problems have the same exact introduction. They just give you different equations. So I'm not going to read this entire thing again. I'll just keep doing the examples given. So this one was number 1. And now I'm going to do number 2. So with number 2, they gave us a labor demand of 25 minus 2W and a labor supply of W minus 8. So again, labor is already isolated, and we know an equilibrium supply equals demand. So we can just combine these two into one equation of 25 minus 2W equals W minus 8. So we can add 2W to both sides. And then also add 8 to both sides. So we get 33 equals 3W. And then dividing each side by 3, we get a wage equal to 11. We can plug that back into either one. So labor supply seems to be a little bit easier in solving for, so that'd be 11 minus 8, which has a labor supply, an equilibrium labor level of 3. So those of you who are pretty familiar with algebra, this is probably super easy for you, which is good. Those of you who haven't seen algebra in a while, it's totally okay. It might take you a day or two or a couple problems to get back into it, but I'm fully confident that you'll be able to do this. So the last 2 problems are also very similar, but what I'm going to do is change them around. So number 3, they gave us a labor demand of 26 minus 2W. And they also gave us labor supply, which is 2W minus 10. Now, if for some reason you had to solve for W and rearrange this equation, so let's say they gave us labor demand with W isolated, and then they gave us labor supply with only L isolated, you can't, if they're isolated for different variables, you can't set each of those equal to each other. So you can't do like something with L is set equal to something with W. Like that doesn't work. You have to make sure that both equations have the same variable isolated. So if you would need to do that for some reason, I'll just show this labor supply one as an example. What you could do is add 10 to both sides. That becomes 10 plus labor supply equals 2W. And then divide the entire thing by 2 to isolate W. So our new equation for W would be 10 plus L over 2. So if you needed to do that, like, that's a simple way. That's how you would isolate W. But with all these problems, labor supply and labor demand are solved out. I mean, labor supply and labor demand are already isolated, so you just need to set the equations equal to each other. But I thought I would just give that information in case anybody was curious. So 26 minus 2W equals 2W minus 10. So we can add 10 to both sides to get 36, and then add 2W to both sides to get 4W. And then dividing both sides by 4, we get an equilibrium wage of 9. Then plugging back in to either equation, which I'll do over here. I'm going to use the second equation. So labor equals 2 times 9 that we just solved for minus 10. 2 times 9 is 18, so 18 minus 10 is 8. Then there is a fourth one, but I'm running out of room, so I'll clear my drawing. So for the last one, number 4, labor demand is 10 minus 3W, and then labor supply is 2W minus 5. We can just set them equal to each other since labor is isolated in both equations. So 10 minus 3W equals 2W minus 5. So adding 5 to both sides, we get 15 on the left, and then adding 3 to both sides, we get 5W on the right. And dividing each side by 5, we get an isolated W variable, which is equal to 3. And then plugging that back into either one, we see that labor equals, I'm going to use the second one, 2 times 3 minus 5. So 2 times 3 is 6. 6 minus 5 gives us 1. So for this last one, we see that the equilibrium wage is $3, and the equilibrium level of labor is 1 worker. So that is all the problems for today. I hope you're able to follow along and this is beneficial to you, but sorry, excuse me. So hopefully this was beneficial for you. You're able to follow along, but that is the end of today's session. The following GSG sessions will be very similar. I just go over the practice problems and give you tips on how to solve them or how to analyze them or understand some concepts. But I do have office hours on Thursdays, which look like they'll be from 9 to 10 p.m. So you can use the same login and link to enter the session. And that is all for today. So good luck with all your studying.